Next is here proxy server. Okay, what is proxy server? It works as an intermediate system between inside and outside world, and it will not allow inside users to go outside directly or vice versa. To better understanding what we have to do, we have to draw a simple diagram. Please have patience. Okay, now you can see in this scenario we have a branch R1 that is connected with switch is connected with the inside users, or we can say here inside client here. Okay, and yes, we have performed here pet. So what happened using pet, these internal lane can access to the internet. Okay, in internet you can see we have different types of servers here. You can see google.com, sorry, facebook.com, youtube, and linkedin. Yes. Okay. If we will configure here pet, simply they can access to all internet use servers here, whether they are good for us or not. Now assume there is a company ABC. They have hired people so that they can do work and they can give profit to the organization, as well as they can get the salary from that profit. Okay. Now what happened? These users are accessing useless sites here. So what we can do, we can't, for to control that, what we will use here, yes, we will use here proxy server. In proxy server there are some categories. First example, social sites, search engine, public mail server, gaming sites, okay, such like this. And here we can say hey, political sites. Okay, by default they are in monitoring condition. So what we can do here, okay, now what will happen when the user will initiate a request? Yes, any client that will initiate a request and that will forward the packet to gateway. Gateway will redirect it silently to the proxy server. Then proxy server check, for example, this host is trying to access google.com. So this request will go to the gateway. Simply this request will go to the gateway. Gateway will go forward it to the proxy server. Okay, now this is the by default policy. All sites are in monitoring. Now, what we have done according to our organization's requirements, social sites, yes, we have blocked. Search engine, we have allowed. Okay, public mail server, yes, we are using, for example, Gmail. Gaming sites, yes, block. And political sites, yes, we have to block. This is our policies. Okay, now what the user is accessing here? google.com. It will request to the gateway and gateway will forward it to the proxy server. Now proxy server will check, okay, its request is Google. What is Google? Yes, Google is search engine. And what is our policy? Yes, we will allow it. Now gateway will initiate a request on the behalf of client and that request will forward it to the google.com. This proxy server will initiate a request and it will forward it to the google.com. Now google.com will give reply to the proxy server, and then proxy server will redirect, or we can say forward it to the client. Same, if another client is here, this one, the second client that is trying to access here Facebook, so simply it will forward the packet to gateway. This client will forward the packet to gateway. Gateway will send this request to the proxy server. Okay, proxy server will check which site they want to access. Yes, Facebook. What is Facebook? Facebook is social site. Okay, what is our policy? Our policy says that is blocked. So it will give reply to the this client that yes, our according to the our organization policy, this site can't be accessible. Same thing you can see here, public mail. For example, this want to access gmail.com, so it will send the packet to gateway. Okay, now what? Gateway will forward the packet to the proxy server. Proxy server will check, okay, which site they want to access. Yes, Gmail. So what our policy says, yes, these are the public mail server. Yes, that is allowed. So here, this proxy server will make a request to the Gmail, and then the Gmail will give reply to the proxy server. Then proxy server will redirect, or we can say forward it to the internal client. So here we can say that proxy server, this server is working as an intermediate system. This server is working an intermediate system between inside and outside world. When the inside client want to go to outside, they will go to proxy, then proxy will go to outside. When server will give reply to proxy, then proxy will forward it to the internal resources. So here we can say it works as an intermediate system between inside and outside world, and it will not allow inside users to go outside directly, vice versa. So this is the proxy server here, working of proxy server limitations. Yes, single point of view failure. If you are using a single proxy, then definitely it is a single point of failure. Next one is here, it introduced delay. As you can see, first connection will initiate client, then the router or our gateway will forward it to the gate proxy, then again second connection is being initiated by the proxy server. So definitely what is here, it will introduce delay. Yes, next firewall technique we have here, stateful firewall. So before understanding stateful firewall, we required a clean diagram here. Please have patience. Okay, now we have a client here that is connected with switch is connected with ASA is same connected with outside switch, and this switch is connected with the server. Its IP 192.168.101.100, its gateway 101.1, its IP 102.1, and its server IP complete 192.168.102.100. Assume this is running web service HTTP. Okay, when this client will initiate a request, so it will generate a source IP. Okay, I'm typing in short, that is 101.100, 101.100. Destination IP, yes, it want to access to the server, so server IP 102.100. Source port, it will add use dynamic port, and it will hit the destination port, yes, 80. And additional information we can say here, additional information, it will send send request. Okay, now this PC will generate this request or this packet will be forwarded to the firewall, or we can say here stateful firewall. Then stateful firewall maintain a state information here. What is that? Okay, source and destination. What is source IP? Yes, 101.100, destination 102.100. Okay, what is source port? 1024, destination port 80. Okay, additional information, yes, send request. Okay, it will add the information, then it will forward this packet to the actual destination. First, client will initiate request for the destination, it will forward it to the stateful firewall, then stateful firewall will add this information in the state table. After adding, it will forward it to the destination. When the destination server will give reply here, then same it will initiate a packet, that source IP here 102.100, destination IP will be 101.100. Okay, now source port will be 80 and destination port will be definitely 1024. This information, okay, along with this information we know that TCP has three-way handshake. Okay, if client is initiating SYN, then it will give yes, SYN ACK. This information will be forwarded to the stateful firewall. When the reply will come at this interface, then this stateful firewall will match reply packet. This is our reply packet with the state table. Okay, who is coming? 102.100 is coming to 101.100. Yes, 1 in this packet. 102 is coming to 101. Yes, 102 is coming 101. Yes, L3 information match. Next, 80 is coming to 1024. Okay, 80 is coming to 104. Now what? Yes, what is coming here? Sin egg. Okay, the client has sent sin. Okay, it know very well that first packet will be here sin, then client will give acknowledgement with sin egg, and then third initiator will give egg. Okay, now it is they are following the rule. Yes, first packet was sin and second is here, you can say sin egg. Yes, now what it will do, if information is matching, then this packet which the client has reverse sent, that is allowed and then can go to the inside host. So here all thing we can obtain or we can hear in stateful firewall, as name tells us that stateful, it maintain the state of the connection when packet is traveling through the appliance. It maintain the state of the connection in state table. After adding information in state table, packet is forwarded to the it forward the packet to the destination. When when it receive the reply packet, it match the packet's information to state table. If packet match, if match packet is accepted, otherwise drop. As I told you, first client will initiate a request to the destination. It will generate a packet. That packet will be delivered to the, yes, that packet will be delivered to the gateway. Okay, or we can say stateful firewall. Then stateful firewall will add this information in state table. It will maintain, okay, what is source, what is destination, what is source port, what is destination port, all information, source, destination, source port, destination port, and additional information. Then it will forward the packet to the destination. Okay, when destination will give reverse reply, source port will be 102.100, destination source IP will be 102.100, destination 101.100, source port will be 80, destination port will be 1024, and it will give SYNAC. When this packet will be forwarded by server to the ASA, so ASA will intercept with the packet. Okay, what is, okay, who is coming? 102 is coming to 101. It will check the database. Yes, 101.100 went to 102.100, so only 102.100 can come to 101. Okay, layer 3 information match. Okay, dynamic port went to 80. Okay, 80 can come to the dynamic. Yes, 80 is coming to the dynamic. Okay, what contain? Yes, initiator has sent sin, so what is coming? Synac. Yes, that they are following the rule. Yes, let the packet allow. Now it will, if information match, it will forward the packet to the destination. Okay, if something happened wrong here, for example any IP change or any information change here, then it will drop. For example, assume at the place of 80 what we are using here, okay, we can use here 88. Okay, now assume here port information change. Now packet is coming. Okay, it will check what is here. Yes, source 102.100 is coming to 101. Okay, L3 information match. Now we have to check L4. 88 is coming to 1024. No, not match, so this packet will be drop here. So this is the stateful firewall behavior. Okay, for better understanding you can go through the PPT. Okay, again I am repeating, a stateful firewall, it maintain the state of the connection when packet is traveling through the appliance. It maintain the state of the connection in state table. After adding the information in state table, it forward the packet to the destination. When it will receive the reply packet, it will match the reply information with the state table. If that match, that is allowed, otherwise it is dropped here. Okay, state table contains, as you can see here, that will contain the source IP, destination IP, source port, destination port, and additional information. Same thing you can see here, source IP, destination IP, source port, destination port, and additional information here. Now next one is here transparent firewall. So what is the use of transparent firewall? To understand better understanding, we required here clean diagram. Please have patience. Assume we have branch 1 that is connected with branch 2, and they are also connected with ISP. Yes, they are connected via ISP, and branch 1 has a lane, Okay, now what we want, this is our established network, and what we have configured, yes, we have configured site to site VPN between two branches, and we have also configured here pet port address, yes, port address translation, so that our lane can access to the internet. Okay, that is up to you, that you can also exceed the configuration, increase the configuration. Okay, now what we want to do, yes, we want to implement firewall in this our trusted network. We want to implement here trusted network. We want to implement firewall in our trusted network. So what we will do, at the place of firewall, or at the sorry at the place of router, we can implement here firewall. But when we will implement firewall at the place of router, we have to configure each and everything, site to site VPN plus pet and routing, whatever, we have to configure it again. But we don't want to do so. So how we can do it? Okay, let the network exist in your pre configuration, and implement the firewall here in trusted network. You can implement firewall here. Okay, and configure it in transparent mode. Okay, configure one interface as inside and another interface as outside. Okay, same, inside security level 100, outside security level 0. So same, just like if request is initiated from inside and that is going to outside, reverse reply packet is also allowed. But if request is initiated from the outside network, that will drop here. So here you can see it works as a L2 device. Here in transparent mode, ESA will work completely as a L2 device. Okay, it forwards the frame. If it is L2, then simply we can see here at L2, the data structure is called frame. So it will send and receive frames. Okay, but still it has capability to filter the traffic from layer 2 to 7. Yes, it is forwarding the frame between two trusted and untrusted network, but it can filter the traffic from layer 2 to layer 7. The advantage of transparent firewall is only this: if you want to implement firewall in your network without readdressing the devices, so you can use here transparent firewall. Thank you. So this was something about firewall and firewall technique. Thank you again.